All right, and with that, I'd like to welcome everyone to our little debate panel or discussion panel where hopefully we will have a friendly conversation with one another. And I noticed some people have joined me up on the stage here, but who are these people? I have no idea. Can you maybe quickly introduce yourself?
Sure. My name is Brian Terlson. I work at Microsoft on the language side of the Chakra Core engine and also on TypeScript. I also go to the TC39 meetings and do that standards work as well.
I think it's a little bit of an understatement to say you do a little bit of standards work. You're the editor of the ECMAScript spec.
True.
I mean, can I get an applause for that? Yeah. OK, and who are you?
Yeah, my name is Benedikt. I already spoke earlier yesterday. You might have seen my talk. I work on the V8 engine, which is the engine in Chrome. And yeah, I do a bit of performance work sometimes.
Another understatement, I guess. Wait, that's an interesting coincidence. You both work on a JavaScript engine? Wow.
Oh, surprise. Yeah.
Wow. Maybe we should talk about that.
Yeah, that's OK. But you mentioned that you work on TypeScript. That's one of the things you do. And we see a lot of developers using things like TypeScript and Flow and our developer tools in their workflows. And you also work on standards. Do you think types is something that should somehow be added to ECMAScript as a language itself? Or should it remain at the build level?
My personal opinion, I think, is that as far as types being in the engine and understood by the engine and used to produce optimal machine code in sort of the same way that a C compiler might, I'm not convinced that that is really possible. JavaScript seems sort of fundamentally opposed to that kind of work. I think probably Benedikt can share some actual data on that based on strong mode investigations. But I think there is a space for types in the tooling space, a sort of erasable type layer like TypeScript has, where there can be you can maybe even see them in the dev tools and get feedback in your dev tools in the browser about what's happening with types, and get errors at runtime for type mismatches and that kind of stuff. I think that's an interesting avenue to pursue. But it is also very difficult to do because we have a lot of type systems now. We have TypeScript, we have Flow, there's also Closure compiler. And these are all kind of occupying the same space, and they all have different ways of doing things. So I think we'll see over the next few years whether there's a kind of coalescing of these ideas and sort of rallying around one sort of system to rule them all, or if, as I actually suspect, there's actually value in having type systems that make different trade-offs. So I think that might be actually an interesting place we might end up.
Yeah, I agree with many things you said. So I don't really see types as a way to speed up JavaScript performance, because you cannot really rely on them, and the types don't operate on the level that the engine needs to operate on. What I see, though, is the value for developers. And I think the missing link that we have so far is that the browser doesn't give you, or the engine doesn't give you feedback on whether you actually, it doesn't validate the types really. So you validate it ahead of time, but then at runtime anything can happen anyways. You can pass objects that don't have that type because those are just living outside of the TypeScript world. And we recently launched a new system that we call type profiling, which you might have seen already. Actually, Apple has this for some time in the Web Inspector. And one use case that we could imagine is we collect the types at runtime, so we know precisely what kind of object we have seen. And we could use this information and combine it with the static information that you have in TypeScript or in Flow, and signal errors if you see an object at runtime that doesn't match the type of the TypeScript declaration, for example. And doing this, I think you can produce pretty good code, because the engine, you keep your code monomorphic just because you use the types to restrict it.
You can get, if you subset JavaScript, like if you get rid of eval, and you get rid of the function constructor, and a few other things, you end up with the sort of JavaScript subset that could be strongly typed. But that doesn't I don't know that many people are interested in using something that's not really JavaScript, and you can't like use JavaScript libraries.
Right. You briefly touched on strong mode before. Is that something you have some more background on?
I don't have a lot of background on strong mode, except that this experiment was discontinued because we found that. So the idea is that we have a subset of subset of JavaScript running in a dedicated mode, similar to strict mode. There would be use strong, and it would be restricted so that many of the things that make your program slow or behave in the wrong way no longer happen. But I think that goes against what the standards committee is currently interested in having this one.js approach.
We also had an experiment on Chakra Core. We had an awesome intern who wanted to investigate what kind of performance gains we could get if we built in types into JavaScript. And these types weren't TypeScript types. These types were actual native types. So he was annotating variables as this is an int32 and this is, an int16 and that kind of stuff. And we found that as long as you just blindly trust the types, which is not something that you can actually get away with in practice, but if you blindly trust the types, you can get some pretty nice speed ups across the board on the order of like 10 to 15%. But the real trouble is we have this awesome ecosystem with so much stuff in it, and we just can't break that. We need to find a way to evolve from where we are, and it's not entirely clear what that looks like yet.
And speaking of standardization, at TC39 there is a stage process for new features to be added to the language. Would you say there is a similar process that happens once a feature starts getting implemented in the engine itself?
A similar process? Like
what kind of stages does a feature go through once it starts to get implemented on the browser side, so outside of the TC39 process?
Yeah, I mean, at least on our team, we usually start with some kind of prototype or a spike. So we'll start doing this work, around stage 3 in the standards process. That's a stage when the committee says we're pretty much done making changes to this, and we really want implementer feedback. And then it's just a matter of getting all the test 262 tests passing after that. No small feat. And then after that, it's an iterative cycle of shipping these features to developers, and developers tell us, hey, this is great, but X, Y, Z. We go fix that, ship it again, and this whole cycle just kind of continues.
So those wouldn't be bug fixes anymore because you already passed the test suite. Would they be more like performance optimizations for common?
Yeah, it's usually performance optimizations. It's really hard to anticipate in advance what patterns you guys are going to be using. Like, it's a hard game to play, and if we try to guess what you might use, we might get it wrong. We might spend a lot of time optimizing something that just isn't important. So this feedback cycle is really important to us so that we can hear from developers how they're using a feature so that we can optimize it and improve ergonomics and other things like tooling and that kind of stuff.
What are your thoughts on that, Benedikt?
It's actually very similar. So we also start looking to new features once they reach end of stage 2, early stage 3. We usually nowadays we try to work together with Babel, for example, to also make sure that things are aligned. Because it would be really bad if you use the feature at stage 1 already, and then you rely on Babel semantics, and then the browser gives you completely different semantics once it hits the engine. On the performance side, we have to wait until some use appears. So even before it hits the browser, we can often see it when we just look at the actual code that people write and then transpile via Babel. But it's hard to estimate what is important. So, for example, we just now start optimizing proxies. Just this year we started looking into proxy performance. And proxies have been there in year 6 since 2 years already. So this is roughly the timeline when we noticed that, okay, maybe it's time to look into how people use it and then optimize the relevant cases.
So it sounds like engines optimized for real-world code, which means that there's a bit of a chicken-egg problem where if there's a new language feature that lands in browsers, a lot of developers, maybe they think, oh, it's not going to be fast yet in engine X or Y, so I'm going to not use it for now and maybe still transpile my code and avoid using this feature directly. But that means that also it won't get optimized. So what is the best way to break this pattern and break this cycle?
So in my experience, since we have evergreen browsers nowadays, you should go for it as early as possible. Maybe just ship it to a subset of the users and see, can you do this? Is this viable? Is this a no-go? And specifically on the Node side, you completely control the version of Node, and you completely know exactly which version of Chakracore or which version of V8 is inside. So it would be nice if you try it earlier and provide feedback, and then we can look into this.
Yeah, I definitely agree with that. And also I find that a lot of times you can get away with using these new features in areas of your application that aren't performance critical. So that's sort of my approach to this problem, is to, because I can't wait to use these features after they get implemented, but I'm not going to be using for of in a hot path, because it's, well, now it's pretty fast, but it wasn't as of 6 months ago. So yeah, I think there is a little bit of a chicken and egg problem, but yeah, just really rely on feedback, and you really can't get out of that problem. Benchmarks are interesting, especially when they go out of their way to try and emulate real-world code as much as possible. But benchmarks just aren't enough. Like, we really need to hear from developers.
And on top of that, I see a danger. One pattern that I see in the wild is when people use Babel and try to optimize the transformation so that it produces the ideal whatever transpiled code. And I think there's some danger in doing that, because long term you don't want to transpile this code anymore, or ideally you shouldn't transpile it anymore. So I see the value in that, but there's also a lot of danger, because then once you stop transpiling, you will be sad, and then you go back to transpiling and you don't make progress.
Right, so the set of features to be transpiled should be a moving window. And I think an easy way for developers to make that happen is to use Babel preset env, which basically it's like auto prefixer for Babel. So you tell it the browsers that you explicitly support, and it won't transpile anything that it doesn't need to transpile. And that kind of solves the chicken-egg problem as well, to some extent, right?
To some extent, it's the performance of the transpiled code isn't particularly relevant to the performance of the feature that you're trying to use. But if you're using something like preset env, it does mean that once browsers catch up, you're going to sort of immediately be opted into this new feature, which is certainly helpful.
Yeah, and on top of that, there are many options to even ship modern code already to modern browsers. So one option that we have been discussing a lot in the past, you can just ship modules to the browser nowadays, and there's a fallback. You can just provide the full transpiled bundle to browsers who don't support modules, but all the browsers that support modules support ES6, so that is a good way to upgrade without breaking old browsers.
So we should be transpiling to two bundles, basically.
Essentially, it produces two bundles, so there's a Webpack sample configuration for this, or there are probably also rollup configurations to do that. And I think this is a pretty safe way to move forward, and it buys you a lot, because the untranspiled code is usually, it's up to orders of magnitude smaller than the transpiled code.
Okay, so that's something that we all can do to to give better feedback and more data to browser developers, so that they can make all these new features as fast as possible.
That'd be great.
Cool.
And I want to stress this again, we have evergreen browsers. Report a bug, we can look into it. If we don't know that there's a problem, then we can never fix it, unless we stumble over it by accident. And then 6 weeks later, up to 12 weeks later, you have the new version, and the feature is optimized, ideally.
That sounds pretty cool. I'm sold. Now, we're here at a conference with lots of JavaScript developers, and we've talked about standardization a little bit earlier. How can the JavaScript community directly contribute to the whole standardization process?
There's a number of ways. In fact, I'm giving a talk at, I believe, 4:30 today on that topic, essentially. But the
spoiler alert.
Yeah, spoiler alert. You should still attend my talk even after I say some things. So The best way is, of course, to just try these features as they come out and give us feedback. But even earlier in the process, TC39 is now entirely on GitHub. All of the standards work that we do plays out on GitHub. Very little of it happens behind closed doors. It's usually just like administrivia and IP-related discussions and stuff like that. So github.com/TC39 has, I think there's like 100 repos now. Like every proposal has its own GitHub repo that you can follow. So if you're really interested in a particular proposal like pipeline or the bind operator or whatever, you can go to GitHub and find that repo and you can watch it, and the issues are used to discuss issues. And pull requests, you can send actually pull requests, and that's fine, we can take those. So that might update you can spend your own make your own spec updates. That's a really great way. Also, like, we're all on Twitter. You can talk to us on Twitter. We have an IRC channel on Freenode. I know IRC is not the easiest technology to use, but we do have that as well. So that's another way.
I remember times when things were different, when the ECMAScript spec was published as like a Word document. It was literally maintained as a Word document with annotations for the diffs. So for each new release, you would have to download it with annotations enabled, go through the annotations, figure out what changed, and then even for small typos, people would have to report a bug and create a tracking issue.
And then the poor editor would have to go and fix it in the Word doc and upload it to somewhere. And now most of my job is just accepting pull requests from various people. So it's pretty nice.
That sounds pretty good. I remember at the time people actually ended up writing a script to turn the Word document or even the PDF version generated from the Word document into an HTML version so that it could be posted online and linked to.
And that actually turned out to be transformational work, because it was that work that enabled us to actually move the spec onto GitHub, because we're not just dumping the Word doc in a GitHub repo, right? We have a whole new HTML spec format and the whole tool chain built on Node to make it like really easy for web developers especially to write spec text and read spec text and contribute.
Right. What other challenges would you say there are when it comes to measuring the real-world performance? Because you mentioned before that there's a lot of micro benchmarks out there, synthetic benchmarks, and they're useful, certainly. But what we really want to optimize for is the real-world performance of the code that people end up writing, right?
Yeah, this is a very complicated topic. So for one thing, there's the web. We can just browse around and check web pages, and we do this. We actually take a web page replay to make it reproducible, and we look into web pages, what they do, like top 1,000 web pages. But we have a lot of trouble on the Node side because we don't have access to your applications, and you should better not give everyone access to it. So getting useful workloads there is very hard. Plus the workloads on the web are just one aspect of the problem. It's not, if you load a web page on your mobile phone, then the engine does something completely different than if you, I don't know, use Google Maps or use Google Earth on your desktop. And the same for Node. And there's also the developer tooling side. So we last week or the week before, we launched the new benchmark suite that is a web tooling benchmark, and we really literally just drop the code that is shipped on NPM into the benchmark and run exactly the code that runs on your machine too, so that we make sure we don't just have a proxy for the application, but we measure the application itself.
So the goal is to make the build times of developers' tools faster? Like when you run npm run build, you're speeding that up?
Yes. So tools like Webpack or parts of Webpack are included. Babel is in, TypeScript is in, Uglify is in, all of the things that take up all the time on your machine, and when you deploy it to somewhere on the continuous integration service, for example.
Right. Benchmarks like these can be used by all browser and engine developers, right? It's not just specific to one engine.
Yep. We've been looking at the web tooling benchmark as well. I certainly appreciate that benchmark, since npm build is, or npm run build is, well, that's my get coffee time, I guess.
Yeah. Does anyone have a question from the audience?
Please
You can raise your hands.
ask us a question.
Come on, asking us a question would be less awkward than not asking a question at this point. So
We're
don't be shy.
just gonna be quiet up here and stare out.
WebAssembly, never heard of it. Have you guys?
What is this technology? I don't know. I love WebAssembly. So like I work on JavaScript, the language side, and I'm kind of a language geek, I guess. So like while I appreciate a bunch of the interesting things with WebAssembly, regarding compiling native applications to run on the web and getting really close to native performance and all of that, really I'm just excited about the prospect of other languages becoming first-class citizens on the web. I think that's going to open up a huge window for innovation from all of you in the audience. And I'm really excited to see what that technology enables.
Yeah, I agree. Personally, I would love to see, like next year or 2019, having one big game publisher publish on the web, like next version of Assassin's Creed runs on the web only. That would be awesome.
Wow. Yeah. How many megabytes would it take, though?
Yeah, that's an unsolved problem, plus all the DRM issues that they have.
Right.
But yeah, so there are some technical details, but otherwise it would just be awesome.
On the other hand, for a game, it's different than for downloading a website where you want to view some content, right? So you might be willing to pay a little bit more and get all those megabytes in.
So I would be fine if it wouldn't run on my phone.
Right.
So that would be okay.
The use case is completely
yeah,
different.
Yeah, it's desktop.
I think there's also a lot of room for these 3D engines have these massive asset pipelines, and I think we're in the very early days. I think we're going to see tooling that's going to enable sort of streaming of game content and that kind of stuff too, to help address this problem of like, hey, if you want to play a game, you probably don't want to download all of those assets again. Like even just checking if it's fresh could be expensive.
Right. That makes sense.
There was a question.
Oh yeah, sure. Okay, so the question is about the binary AST proposal, just so everyone hears.
Any comments on that? How is that progressing?
Okay.
Maybe also something like specific, what are the difficulties? How will you implement it?
Okay, so what is the status of the binary AST proposal at TC39, and what is your stance on it for both of you?
So I don't know, you can probably talk to the state, but my personal opinion on it, I think it would solve some really hard problems that we currently face in the JavaScript land. But for every new thing that we add, it also adds a lot of new problems that we then have to solve as well. So while I'm generally in favor of it, I'm not the expert there, so I leave it to the expert to decide. And maybe Brian has a better opinion on this.
I'm also not an expert on this. So the basic idea of this proposal is, what if we, instead of shipping JavaScript source code to browsers, what if we shipped some packaged binary that includes that source text, but also additional information that is sort of shoved up front so that engines don't need to scan over all of your code and collect all of this information about like what variables have you captured and are you using eval in this scope and all of this sort of information that our runtimes need to produce optimal code. It's a great idea. Like I definitely agree that this is an actual problem. Like this addresses, like the goal of this proposal is to address that parse time bottleneck that many of you with massive code bases are feeling. It can take seconds to parse JavaScript on mobile devices on some big properties. So like that is not a good situation. But in terms of difficulties, what I'm really interested to see is how this proposal will handle all of the different kinds of information that engines need to collect, because we all actually collect slightly different information. because we just have different implementations and different trade-offs. So I think this proposal will only work if it is a sort of superset of all of the information that all of the implementations need to collect in order to produce optimal code. I'm not super convinced that that's possible, but I think Mozilla is going to work on a prototype. And once that prototype comes out, I think we'll know a lot more about how feasible this idea is.
And what's the current status of the proposal? Is it at stage 0 or 1?
It's probably stage 1. I don't remember offhand. It's really easy to get to stage 1. Stage 1 is, yeah, we agree there's some problem here, and there's definitely some problem there.
So let me say one thing. There will be a session in the deep track by my colleague Maya on the parser, so that would be an ideal question for that session.
Oh, yes.
Okay, and with that, I would like to thank you for your cooperation during this debate.
Oh, such a debate, yes.
Such a debate, yeah. It sounds like you agree about a lot of things.